Today we shall solve a problem based on continuity equation. So let me write down the problem here. So we have a problem as shown here. So let's read the question. A jet of water having velocity 12 meters per second exit from the diameter nozzle. So this is a nozzle, you can see. Water exit from this nozzle with speed 12 meters per second as given in the question. And jet of water is moving in the vertically upward direction, and we are assuming that the jet remains circular and we neglect losses of energy, as it is mentioned that the energy is conserved. The total energy at the section 1 and the total energy at section 2 are same. They are same because the energy is conserved. So as given in the question, we have to find the diameter of jet at 5 meter above the exit of nozzle. That means at section 2 we have to find the diameter. The height of section 2 from section 1 is 5 meters. Now they have given in the question that the exit velocity of jet, let me call it as u1, is 12 meters per second, and the velocity of jet at section 2 is u2. So u1 is 12 meters per second. The diameter of exit of nozzle is given as 25 mm, and we have to find the diameter at section 2, which is 5 meters above the exit of the nozzle. So friends, in order to understand this problem, let me show you the nature of the problem. So here water jet is coming out from the nozzle in the vertically upward direction, as you can see, and if I consider a single particle of water, it is moving in the upward direction with velocity u, and it is moving against the gravity. So gravity is acting in the downward direction and it travels a height h. So we have seen that fluid particle is moving in upward direction. So when fluid particle is moving in the upward direction, the gravity is acting downward. So we can use the kinematical equation in the upward direction and we can find out the velocity at section 2, that is u2 we can find out. So let me use the kinematical equation for a fluid particle moving in the upward direction. This is a fluid particle, let me assume, and it is moving in the upward direction. So we have the kinematical equation v square equals u square plus 2as, where v is the final velocity of the particle, which is u2 in this case. U is the initial velocity of the particle. So in the given case it is u1, and a is the acceleration of the particle, where it is minus, here it is minus g, and s is the displacement in the vertical direction. It is given by height. So when particle goes from section 1 to section 2, we can write down the kinematical equation as u2 square equals u1 square minus 2 gh. Here g is the gravitational acceleration and minus is because the gravitational acceleration is acting in downward direction. So we can substitute the value. So initial velocity u1 is 12 meter per second, so it is 12 square minus 2. The value of g is 9.81, and then height given as 5 meters. So if you substitute, you will get the final velocity of fluid particle at section 2 as 6.775 meters per second. Now by using kinematical equation, we got the velocity of fluid particle at section 2 as 6.775 meters per second. Now we can use the continuity equation of fluid across section 1 and section 2. So we know that the volume flow rate across section 1 and section 2 is constant. So we can assume this as system. fluid is entering across section 1 and fluid is leaving across section 2. So by conservation of mass or by continuity equation, the volume flow rate at section 1, that is Q1, is same as the volume flow rate at section 2, that is Q2. So therefore, by using continuity equation, discharge across section 1 is same as discharge across section 2, that is volume flow rate are equal. So discharge is given by area into velocity at a given section. So A1 U1 is same as A2 U2. So we know the diameter at section 1 and we have to find the diameter at section 2. So area at section 1 is given by pi by 4 d1 square. U1 equals pi by 4 d2 square times U2. So pi by 4 d square is the area at a given section. So we can cancel out pi by 4 from both sides. So we get the expression of d2. If we simplify both sides, we get d2 square equals d1 square times u1 divided by u2. So you will get the expression of d2 as d1 times the square root of u1 by u2. And if you substitute the values of u1, u2 and d1, so we have the value of d1, u1 and u2. So by substituting the values, you can get the value of d2. So d2 is, now d1 is 25 mm, so it is 25 into 10 raised to minus 3 meters times square root of u1. u1 is given as 12 meters per second and u2 we have calculated as 6.775. So if you solve this, you will get the value of diameter at section 2 as d2 equals 33.27 into 10 raised to minus 3 meters. This we can also write down 33 mm if you want.